All right, so one more quick video is to actually solve equations. So there's two ways of solving this equation. I'm going to show you the algebraic way, and I'm going to show you the, well, I don't know, pre-calculus way, or the complex number trigonometric form way. Okay, so one way is algebraic, and it's not always going to work. Okay, this works because it's factorable. So in fact, as you see, 8 is the perfect cube of 2, so that's a sum of perfect cubes, which you are allowed to factor into an x plus 2 times x squared minus 2x plus 4. So I hope you know the factoring of perfect cubes formula, okay? So that's possible just because 8, again, is a perfect cube. Put a 7 in there and you're done. You can't use this algebraic form or solution. So then what are the possible answers? One is -2. What are the other two? Well, solving this quadratic equation, which is never factorable. So, by the way, it won't even have real solutions. There's only one real cube root of a real number, and well, this one's a -2. So, solve the quadratic formula. So it's -2 plus or minus the square root of -2 squared minus 4ac over 2 times a. Okay, so that's going to be a 2 plus or minus the square root of 4 minus 16, and that's a -12. So I'm quickly solving this. That's a 2 plus or minus. I'm going to throw out a 2 from the 4, an I because of the negative, and that's a square root of 3. Now when you divide them both by 2, you'll get a 1 plus or minus I radical 3. Okay? And again, this could be done because we could factor this as a sum of two perfect cubes. Great. Now, what would be the complex number, right, trigonometric form method? So let me show you. Let's start this again. So I want to solve this equation, yes? Now, one way of solving it is to move 8 over to the other side and take the cube root on both sides. So what do we get? We get the x is, what's the cube root of -8? I just said it. The cube root of -8 is -2. But that's just one of the answers to this equation, yes? How do I get the other two imaginary answers? Well, I'm going to show you. So this we know the only real number whose cube is -8 is -2, right? We are stumped right there. So it turns out there are always nth roots of a number, any number, real or imaginary, doesn't matter. Not all of them real, right? So some might be complex numbers. So there's going to be 3 cube roots of -8. There's going to be 10 cube roots of 5. Not all of them. I'm sorry, what did I just say? 10th roots, right? So if I want to find the 10th root of 5, yes, I'm going to get 10 answers. That's what I meant to say, okay? All right, so let's see. It's getting dark in here. It's getting late. So how do I find them? Well, I have to use the complex form of this number. So I'm taking -8. And I want to put it in trig form. Okay, so what's the trig form of this? There's one quick way of figuring this out. Where is the number -8? -8, by the way, is down here, yes? Here. Okay, so what's the absolute value of this number? In other words, what's the distance from the origin all the way here? That's 8 units, yes? What is the angle from the positive x-axis all the way back here? That's 180 degrees, right? So just like that, you found the trigonometric form of this number. You found the absolute value, and you found the angle, right? From the positive x-axis all the way up to it. You can go through the whole tangent, inverse, and the square root of x squared plus y squared, but that's, again, sometimes, as I said, if you just graph it, it turns out that it's pretty simple to figure out the answer. So this number, -8, can be written as what? 8 cis of 180, yes? Now, remember what I had said. I put that formula somewhere there, that if you take the nth root of it, what do? You take the nth root of it and then take the angle and divide it by n. So here it is. So the nth root of this number, or the cube root of 8, will be the cube root of 8 cis of 180 degrees divided by, well, by 3, right? That's the cube root. Except for that gives you just one answer. So how do I make sure that I get all my answers? This is the same exact idea that we used when we solved trigonometric equations of multiple angles just now in section 7.5. Now, one possible answer is 180. What's another possible answer? 180 plus 360. And another one plus 360. So you have to find the general solution. And let me show you how pretty this is. Now, what are my choices for n? My choices for n will start at 0. So if I start at 0, what do I get? The cube root of 8 is always 2, yes? Cis of 180 divided by 3 is 60, yes? And that's plus 0 divided by 3. I'll rewrite this in a minute. What if n is equal to 1? Then I get the cube root of 8 is 2 cis of what? 60 plus, when I use a 1, that's 360 divided by 3, that's 120. So that's 2 cis of 180, okay? And then when n is 2, I get cube root of 8 again is 2 cis of 60. Here I should have written plus 0 for you just to see. Okay. That's a 60 plus, I'm using 2, right, of these 360s. So that's 120 times 2 is 240. So all these answers are off by 120. So that's 2 cis of 300 degrees. All right. So what I want to do is I want to rewrite all these answers back into rectangular form. I wish I would have left myself a little bit room there, but I didn't, so I'm just going to write it below. What's 2 cis of 60? It's 2 times, what's cosine of 60? Cosine of 60 is 1/2, plus what's sine of 60? Sine of 60 is square root of 3 over 2, so I'm getting a 1 plus I square root of 3, yes? 2 cis of 180 is 2 times. What's cosine of 180? That's a -1. What's sine of 180? That's a 0. So I'm left with -2. Okay. 2 cis of 200 and, no, not 300. Cosine of 300, that's fourth quadrant, it's positive. Reference angle is 60, so that's a 1/2. Fourth quadrant sine is negative. Reference angle is that, so that's a square root of 3 over 2. So distribute that in, and you'll get a 1 minus I squared of 3. So these are my 3 answers. Now, what I really want to do is go back and compare. Oh, there it is, there it is. So here's the answers that we used, that we got using the trigonometric form of the number -8. And here are the answers that we got. -2, yes, was one of them. And what are the other two? 1 plus I squared of 3 and 1 minus I squared of 3. Same exact answers. Now, as I said, we could do this because it so happened that 8 was a perfect cube and we have this formula from algebra. But that's not always the case, right? If you don't have perfect cubes, well, you are in trouble. So let's try one more really quick. I know, but it's good for you. More practice, better. So I just need one more paper. Here it is. Really quick. What else should we do? Find, whatever, here. I don't want to do something that can be done algebraically. Find the 5/5 roots of the number 6. So if I take the 5th root of 6 and put it in the calculator, that's going to give you just one answer. And that one answer is whatever your calculator says, 1 point something, 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 right? So that's all, right? But apparently, how many 5th roots will this number have? 5. The other 4 have to be imaginary. So that's really another way of asking this question. What if I'm asking you to solve this equation? X to the 5th is equal to 6, right? Now, x to the 5th is equal to 6 should have 5 solutions, right? It's a 5th degree equation. Now, of course, one of them is to take the 5th root and put this in your calculator, and you got that. But that's just the one real answer that your calculator can find. The other 4 have to be imaginary. So, how do I find them all? Easy. Take the number 6 and put it in trigonometric form. So 6 is a complex number, right? The real numbers are complex numbers, the ones that have 0 imaginary part. So 6 plus 0i. By the way, again, what I need to figure out is where is 6 plus 0i? Right here. So 6 plus 0i has an absolute value of 6 and an angle of how much? 0 degrees, right? That's it. So to find the 6 roots of it, I'm sorry, the 5th roots of it. So it's the 5th root of 6. And then what do I do with the angle? I divide this angle by 5. But that's just the first solution, right? How do I get all the other ones? I have to write the general solution, yes? So it's not just 0, but it's 0 plus 360n. Yes, those are all the coterminal angles to this angle, right? Go again, and go again, and go again. So that's the general solution. Now, I'm going to get 5 answers. Why? What are my 5 answers coming from? Making n equals 0, 1, 2, and all the way up to 4, right? Once you get to 5, this wraps itself around. You're back at the beginning. So, what is the 5th root of 6? I don't know. Your calculator knows. When I plug in a 0, yes, then I simply get my original real answer. That's it. This is the one real answer that would have come out of your calculator. That's it. Put it in your calculator and you'll get something. What's the next solution? Whatever the 5th root of 6 is times cosine of plus I sine of 0, by the way, over 5. That's always going to be a 0. And all I'm going to do is add this. So 360 divided by 5. 1/360 divided by 5 is 72, right? The next one will be another 72 degrees away because it's 2 360s divided by 5. So that's 1, 4, 4, right? And then the next one is what? Put this then in your calculator. The square root of 5, the 5th root of 6, 6 of, add another 72 to this, so 21, 6, boom. This is how quickly I'm getting these answers. Whoops, 3, 4, wait a minute, I skipped something. 1, 2, 3, no, I'm done. 4, the 5th root of 6, says of add another 70, it's 288, right? Okay, if I'm going one more, just to show you, if I was to do a 5, if I add another 72 to this, that's going to be exactly 360, yes? So what's this of 360? That's the same thing as the 0 I had up here. So that's no different than my first one. So how many answers do I have? 5 of them. How do I find them? Put this in your calculator, right? The 5th root of 6 cosine of 288 is something, plus I sine of 288 is something else. Put in your calculator, and you have the x plus y I answers for each one of them. So that's pretty cool. All right, that's, again, how fast you can compute once your answers are in trigonometric form. And again, real numbers are complex numbers, so they have their own trigonometric form, right? It has a 0 argument, but yes, that can be extended and do a lot of stuff with it. So here is section 8.4.